Hey. All right, so what in the world does this stuff even mean? So do you remember when we were solving quadratics, right? So first of all, remember what a quadratic even is. That has its highest exponent as a 2, right? So remember solving quadratics? That was the whole last chapter that we did? Yes, right? Okay, good. So when you have a quadratic and you graph it, it's always a parabola. So when you solve that quadratic by either factoring, square root, and quad formula, or completing the square, you always got 2 answers. And those 2 answers were really these 2 numbers, right? Where the parabola is crossing the x-axis. Do you remember all this? Is that ringing a bell? Yes, okay, good. So we're doing the same thing now, but now they're not just quadratics. Maybe it's a cubic function, maybe it's quartic, maybe it's quintic. So the important things to know is that we are still finding where the graphs cross the x-axis. We're going to talk a lot more about this next week, but if I have, let's just stick with a quadratic function for a second. So if I have a quadratic function, that's degree 2. That means the most number of times it could cross the x-axis is 2. So when I solve a quadratic, I'm looking to get 2 answers. If I solve a cubic function, I'm going to get 3 answers because my highest degree is a 3. If I had a quartic function, I'd be getting 4 answers, and so on and so on and so on. Everybody good so far? Okay. So today we're going to look at 2 different ways to solve polynomials. First is if I happen to have the sum or difference of 2 cubes, we can factor and solve from there. And factoring by grouping, which you already know how to do. So here's some ways, or I guess it should be here are some ways. Here are some ways to solve. We're going to start off with the sum of 2 cubes. We'll come back to the difference in just a minute. Do you remember what cubes even are? So remember how like perfect squares were 1, 4, 9, 16, 25, all those, remember? So perfect cubes, same thing, but now I'm cubing the number. So 1 cubed, 1 times 1 times 1 is 1. So 1 just so happens to be a perfect cube. But then what do you get when you do 2 cubed? 8. So 8 is a perfect cube. Get what I'm saying? So what would the next one be? 27, because 3 times 3 times 3 is 27, right? So if you just so happen to have 2 numbers that are cubed and you are adding them together, turns out there is a very nice formula to factor that apart. So I'm going to give you the formula and then we'll practice a bunch of them until you get the hang of it. Okay? So sum of 2 cubes, thank you, is going to look like this. I'd have a plus b, and then in my next one, I'm going to have a squared minus a times b plus b squared. I know this looks like a lot at first, but once we practice a few of them, it'll make more sense. So when you have the sum of 2 cubes, it factors into these things. So let me give you an example with numbers. And we'll start off with a real easy example. Let's say I had the polynomial x cubed plus 8. Oh, I'm always going to be fighting the light. There we go. All right. Is x cubed a perfect cube? Sure it is. What's the cube root of x cubed? just x, because x times x times x gets me x cubed. Is 8 a perfect cube? Sure, we just went over that. It's then what's the cube root of 8? 2. So that's actually where you start. You're going to figure out what's the cube root of each of these terms. So the cube root of this one is going to be a. So the cube root we just said was x. And the cube root of this one, I'm going to put in for b, which we just said was 2. So I am find the cube root of each. Oh, sorry. So now let's just follow this. Yeah, sure. Let's follow this pattern and see if we can figure out how x cubed plus 8 factors into these two things. All right. I'm going to give everybody a second to make sure you're with me so you can watch this. Because it's weird the first time, but then you'll get the hang of it. Okay, you ready? All right. So I need a plus b. We just said that a is x, so I'll have x plus, in this case, b is just 2. Does that make sense? So I just have the cube root of each one. I have x plus 2. And then in my next thingamajiggy here, I'm going to take whatever a is and I'm going to square it. So in this case, a is x, so x squared. And then for this chunk, you want to multiply a and b together and just subtract that answer. So x times 2 is 2x, right? So then in my formula, I just write it as a minus 2x. And then in my last spot here, I have plus b squared. So that's 2. 2 squared is just a 4. Huh? How's that? That's it, Sylvia. Sure. No problem. Bye.
I'll wait for it.
Good.
Zero fear. Absolutely not.
All right. So if I were to multiply these two things back together, guess what I'd get? I'd get right back here. All I've done is factor this. It's just weird to think that this actually factors into these two things. I am going to multiply back together just to prove it to you, because I feel like if I were you, I'd be very skeptical. I'd be like, yeah, okay, when you multiply these two things together, it's going to come back to just this. Seems unlikely, lady. Well, you don't have to write this in your notebook if you don't want to, but I'm going to show you. So if I do x times all of this, that's x to the third minus 2x squared d2 by plus 4x, and then 2 times all that. 2x squared minus 4x plus 8. And then if I combine like terms, look what happens. Minus 2x squared plus 2x squared plus 4x minus 4x. Oh my gosh. It really does. Wow. I know, isn't it? It feels like it really shouldn't, but it totally does. So let me give you another pretty easy one to try, and then we'll try some trickier ones. What if I gave you something like, let's go x to the third plus 27. Everybody tried that one. So use what we just did above as sort of a guide. And you're trying to come up with this. Trying to factor that into which two factors you get there. Okay, did you get an answer? All right, so I'm basically going to do the same thing that I asked myself. I got to figure out the cube root of each of these things first. So this, if I take the cube root of x cubed, we obviously know that's x because we just did that one. And what is the cube root of 27? What is it? 3, right? Because 3 times 3 times 3 gets me 27. So now I know what I'm plugging in for A and B. And then if I have the formula in front of me, hopefully it's not too bad. So first I'm going to add A plus B. So that's just X plus 3. And then in my next one, I want X squared. And then I multiply these two together. So that's 3X, but I always write it as minus 3X. And then I just add that thing squared. Ta-da! Now, what is so cool about this? Because remember what I'm trying to do here. I'm trying to figure out where this thing is crossing the x-axis. I claim you know where this thing is crossing the x-axis at least one of the times. You can just look at this now and you know what one of the answers is. What is it? If I graphed x cubed plus 27, where would I be certain that this graph would cross the x-axis? At? I thought you were going to say something. Do you have a guess?
Great, I know you're thinking. What's the question?
If I was based on this, I claim this thing it could cross the x-axis up to 3 times. I claim I know where one of those places is because of this.
0 times 0.
What'd you say? Luke?
0 times 3.
You're close. -3. Right. Well, think back to quadratics. When you factor them, didn't you set each factor equal to 0 and then solve each one? So wouldn't the solution that comes out of that be a -3? Right? Remember this? Now this, I would just have to do the work, but I'm going to get 2 more answers from that. So this, I could try to factor it again, but I'm going to tell you right now, it's not going to factor. So then I would have to either do quad formula or complete the square to get my 2 next additional answers. Get what I'm saying? Yeah. Okay. So this thing would definitely cross at -3 though. And then I'd have to solve this one and see where those 2 lead me. But I'd have at least one of my 3 answers. Isn't that neat? Wow. Okay, let's try a trickier one where we factor. All right, let's do, how about 8x cubed plus 125. Huh. So again, start by figuring out what the cube root of each term is. Whatever that cube root is, that's what you're going to pop into the formula for A and B. All right, so what is the cube root of 8x cubed? 2x. So that's what I'm going to pop in for A. What's the cube root of 125? 5. So that goes in for B. All right, so let me zoom in a little bit. And then according to my formula, the first chunk is just A plus B. So that first chunk is just going to look like 2x plus 5. Is that okay for everybody? Yeah. And now your next one, you need A squared. So what is that? Someone tell me what A squared is. Well, A is 2x. So what do you get when you do 2x times 2x? 4x squared. Yeah. So this first chunk should be a 4x squared. And then I multiply these 2 together. So that's just 10x. But it's going to always go in as a minus. So it's minus 10x. And then I'm just gonna add the b squared on the end, so that's a plus 25. And there is that thing factored. So just looking at this, can you give me one place where this graph is gonna cross the x-axis? You can, what is it?
-2.
Yes! This, if I set that equal to 0, I'd minus 5 divided by 2, negative 2.5 will come from there. So if I'm graphing, I'm putting a dot at negative 2.5. I know it's going to cross the x-axis there. It's going to cross the x-axis up to two more times over here. I just would have to solve this. I'd probably do quad formula on that, right? Because it looks like a nightmare. So if I had to solve it, I'm doing quad formula there, and then I'm getting my answers. Does that make sense? Everybody's with me? Okay. Why don't we do one where we actually do solve it all the way down? So, because here you're just factoring, you're not actually solving. So let's solve it. I'll give you a new example. I'll try and pick one where the numbers are kind of nice. Let's do x cubed plus 64 should be okay. Oh, sorry. So let's try it. First, we're going to factor this. So everybody come up with what goes in here. So we have the cube root of each one. When you pop it in the formula, remember it's a plus b. So that's x plus 4. And then over here, a squared. Multiply these two, just write it as a minus. And then square that. All right, so one of my three answers I already know right away. It's super easy. Oh, wrong way. What's one of my three answers?
-4.
-4, right? I get that one from this factor. Now I need to come over to this thing, and you can try and factor, but I'm going to tell you right now it's not going to factor. But I mean, you can always try. But I could do completing the square on this. That would actually be a really nice one because A is 1 and B is even. So completing the square will not be so bad. So hopefully you remember how to do it. You got a minus C to the other side. Then remember, I need that magic number. So I want half of this squared. So that's 4, right? So we're going to add 4 to both sides. So now I get x minus 2 squared equals a negative 12. Square root both sides. Thank you. Thank you. And then I just got to add that 2 back to the other side. So 2 plus minus 2i root 3. Right? I didn't mess that up, did I? Double check me. No, I don't think so. So there are my two other answers. 2 plus minus 2i root 3. So what does that tell me about this graph? The only time it actually crosses the x-axis is at -4 because these are imaginary numbers. So when it's imaginary, that just means it's never going to hit again. So it'll only hit at the real numbers. Okay, so far so good. Now there is the difference of two perfect cubes, which luckily is the exact same thing. It's just a slightly different formula. So if your original was a difference of two cubes, so that would look like a cubed minus b cubed. Your formula is adjusted as follows. It's now a minus b. And then these are all positives, a squared plus ab plus b squared. So if you compare the two formulas, it's actually pretty much the same. It's just that this is now a minus and this one becomes a plus. But the way I operate is pretty much the same. So let's do an example or two of these, and then we'll be done with that part. So I don't know, how about we do, let's do 27x cubed minus 1,000. Which seems wild, but it's really not that bad. What's the cube root of 27x cubed? 3x. And what's the cube root of 1,000? It's just 10. Now, kids always get hung up on the fact that it's negative. The negative just means I'm going to use this formula. I'm just looking at the numbers by themselves. That sign in the middle just tells me if I'm going to use the difference formula or the sum formula. That's it. I'm just looking at the number, okay? And then I pop it in the same way. So a minus b would be a 3x minus 10. And what's a squared in this case? Ooh, 9x squared, right? Because we're doing 3x times 3x, so that's a 9x squared. Multiply the two together, so that's 30x. And then b squared is 10. I mean 100, just kidding. Thoughts? A little weird, but not that bad, right? Hopefully, fingers crossed. Let me give you one difference one to try on your own, and then we'll move on. How about, I don't know. How about x to the third? Oh, I know. What if we did something like 125y cubed? Oh, try that one. Okay, so let's just see how you did on this. Who thinks they have an answer? Who wants to give me their guess? Go ahead, Izzy. Yeah. It's perfect. So double check if you had that, right? The cube root of this is just x, and the cube root of this whole thing is just 5y. So that's, oh, sorry. Putting in that in for a, that in for y, I mean b, and then just follow the formula. Hooray! Okay. I gave you this worksheet. Why don't we look at number, let's just look at number 1. Number 1 is not a sum or difference of cubes at all. It looks like this. You've got x cubed plus 5x squared minus 4x minus 20 equals 0. And my claim is that you actually already know how to do this. Let's line this up here. There we go. You know how to factor this. Do you remember? I'll give you a hint. These are the ones, when you have 4 terms, you're always going to try to factor by grouping. So when you have 4 terms, remember we put this line right after the second one and then we just factored each side? Do you remember that? So on this side, what can I factor out of the left? X squared. Let's take out x squared and then what would I have left?
X plus 5.
Yes, x plus 5. What do you factor out of the right? -4, and then what's left? X plus 5. Do you remember this? From when we were factoring quadratics and you did 8 times 3, right? Cut in half. Yeah. Anyway, these 2 parentheses should match. If they match, then this is a 4-term polynomial that you can factor by grouping. Just like with trinomials, not everything could be factored, right? Not every 4-term polynomial can be factored this way. However, since this is the worksheet, all of the ones that are on here can be done this way. So my 2 parentheses match. Great, that's one of my factors. So one of them is x plus 5, and the other one is just what's out in front here, x squared minus 4. Those 2 things come together to make my other binomial. So that's where those come from. And now I have this 4-term thingy factored into this. This x squared minus 4 just so happens I can factor that one further, can't I? What does that factor into? I can split that into what times what? I have x minus 2 and x plus 2. Remember that? Difference of 2 perfect squares? One's a plus, one's a minus. We just take square root of each. So now, everybody, this crazy 4-term polynomial that we started with has factored into these 3 nice, neat little factors. So if you multiplied all 3 of these back together, it would get you back to this original. But I'm not trying to do that. I'm trying to solve this thing. I know what my 3 answers are. Isn't it going to be -5, +2, and -2? How cool. Do they all work out so nicely? Not quite as nicely, but the factoring by grouping is the same idea. Split it in half, factor each side. Let's try another one. How about, okay, we'll try number 3. Why not? Let's move this over. It's never like, that's gonna be crooked, whatever. All right, number 3 is 2x cubed minus 6x squared minus x plus 3. So go ahead, draw your line and see if you can factor both sides. I'll give you a minute to try it on your own and then we'll do it together. Did you get somewhere? What can you factor out of the left?
2x squared.
Yes, 2x squared, and I'd have what left? X minus 3. Now, over here, what am I going to take out? -1. Now listen, because I think this happens once on one of your homework problems. If that's x minus 3 right there, and that's already x minus 3, and there's nothing for me to pull out, what do you take out? In this case, I'm going to take out a -1, but if they were already matching, you just take out a +1, right? If that was x minus 3 and that was already x minus 3, you'll see in the homework problem. So if you're like, oh, there's nothing for me to take out, there always is. You can always take out a +1. Anyway, in this case, I'm going to take out a -1, and that switches these to be the x minus 3 that I need. Then I'm like, oh, yay, my parentheses match. So one of them is x minus 3, and the other one is 2x squared minus 1. Now this one's a little bit more inconvenient because this doesn't just factor nicely into 2 other things, but it's okay, I can still solve it. I know one of my answers already is going to be a positive 3 from right there, right? That's easy. This one, I have to do a little bit of work. 2x squared minus 1, I set it equal to 0. And now we're just going to solve. It's just slightly annoying, but it's okay. You know what? We are confident math students. We know we can do this. What do I do right here? How do I get the, let me focus this. If I have x squared equals a half, what am I supposed to do now? Square root both sides. It's annoying because I can't have a square root in a denominator. So remember, you guys multiply by square root of 2 over square root of 2 to like undo that. So I get square root of 2 over 2. And when I take a square root, what do I need to remember? When I take a square root in a problem, I need to remember plus minus. These are my other two answers, positive and negative, root 2 over 2. I was supposed to have 3 answers. I do, right? I knew I was going to have 3 answers because that was the degree of my original problem. So there they are, 3 and then positive root 2 over 2 and negative root 2 over 2. If you forget the plus minus, you'll only have 2 answers. And then you'll be like, I was supposed to have 3. Oh yeah, I just forgot plus minus, no big deal. I have one more problem to do with you and then I'm done. That's it. That's it. Oh my gosh. Okay, ready? I got to flip the page. I just wanted to do number, I don't know. Let's do, I don't remember which one I did with A block. 20? Maybe it's 20. Let's do 20. So if I'm going to do number 20, it says y equals 5x to the third plus 11x squared minus 12x. If I'm trying to solve this thing, what is the very first thing that's jumping out at you that you're like, oh, I should? Yes, take out an x. So I'm just going to replace the y with a 0. Let's pull out an x. So I get 5x squared plus 11x minus 12. And now this thing in here is just a quadratic that I can solve using all the ways we learned in the last chapter. This is one of my answers. How many answers should I have altogether? 3. This tells me that one of my answers is 0. This thing is going to cross the x-axis at 0, and at 2 other places, I'm going to figure out what they are right here. So that now I have to take this thing and I could either try factoring it, I could do quad formula, I could do whatever. So, oops, sorry. Does this thing factor? Factors of -6. Oh, I think it does. I'm going to do slide and divide. Wouldn't I do a positive 15 and a -4? And because I did the slide by 5, now I got to do the divide by 5. So my factors are actually x plus 3 and 5x minus 4 and the x that I had from before. So there's my 3 answers. Oops, so sorry. There's my 3 answers. I get a 0 from that. What do I get from this one? -3. And then what am I going to get from this one? 4/5. Yes. I picked the wrong example because the example I did with them had this thing that pops up. But I just want to tell you, if you get the same answer twice, which can totally happen, it's called the double root. You could get the same answer 3 times, 4 times, 5 times. And then we wouldn't call it a double because double is only if you have it twice. So if it happens multiple times, we literally use this fancy word called multiplicity. So twice it's called the double root. 3 or more, we say multiplicity of whatever, however many number of times it pops up. So for example, let's say, let's just pretend that my factors were x minus 3, x minus 3. Oh, let's pop an x cubed there. Oh, perfect. Let's say those are, I do all my factoring and these are my answers, right? So check this out. Having an x cubed, what is the answer that comes from that? Let's rewind. When you had this, when I had a single x out there, didn't that give me a 0 as an answer? If there's just an x hanging out in front, that means I have 0 as one of my answers. This, if I had something like this, that means I'm getting an answer of 0 3 times. Because that's x times x times x, and each one of those x's represents a 0. What? I know. So we would say from that, I'd say I have a 0 with a multiplicity. I know it's a lot of words. Multiplicity. Am I even spelling it right? Of 3. And then from these two, I get an answer of positive 3 twice. So then I could say 3 as a double root. So all together, how many answers do I have? I have 5. I got 0 3 times, and I got 3 2 times. So that has a total of 5 answers. That must have been a quintic function when I started. Okay, you ready to try some on your own? I'll take that as a yes. I believe for A block, I gave them the homework of, I think it was odds on the back. Yeah, I think that was it. So let's do odds on the back, and then once you're done, you're done. Isn't that so nice? Oh my gosh, the weekend is so close. So give it a try. If you get stuck, let me know. I have the answers to these. All right, let me just put this over here. If you want to do your work on this piece of paper or on a separate piece of paper, whatever works for you. I will also post these notes in just a second. We'll be on our way. I want the light on? Okay.